tree because there's a reason they fall in a certain family. So we had the parallelogram we've talked about extensively. How many properties were with the parallelogram? It's in that pile, Mike, right over there, that first pile to your right, the single digits. Okay? Yeah. All right, just 5. I think yours might be on top, actually. Yep. All right, all yours. Yep. Parallelogram, how many properties? 5, right? 5 properties. The reason the rectangle and rhombus are underneath is because their properties are, the parallelogram properties are also properties of a rectangle and of a rhombus. So that is what you're going to see here. The first 5 properties I've listed, these are all parallelogram properties. Those also exist in a rectangle and a rhombus. But first, let's talk about the rectangle, because a rectangle has a few other properties that the parallelogram does not, and only for a rectangle. And they are, I think you know the first one, all the angles in a rectangle are right angles. Okay, so it has all right angles. Okay, all right angles. Here's a couple of probably that you did not know. When you draw in the diagonals of a rectangle, they are congruent to each other. Okay, so the diagonals, when I draw them in of a rectangle, are congruent. Now, I want to go a little bit deeper here with you. They are congruent, and because it's a parallelogram, they also do what? They bisect each other, because that's a parallelogram property. So, you tell me, if they're congruent and they cut each other in half, what do I know about these 4 pieces here? They're all congruent to each other. And that leads me into the 4th property, which I do not have down, but you are going to write down for me, which is the diagonals form 4, what do I have up here? What type of triangles? Isosceles triangles. The diagonals form 4 isosceles triangles in a rectangle. Why is that good to know going forward? Because what do we know is across from those congruent sides? Right here, right? So these angles would be congruent. These angles right here would be congruent. All right, so remember that in a rectangle, they form 4 isosceles triangles. So any questions with the rectangle? It's a parallelogram. That's the one thing I'm going to keep harping on, and it's going to get annoying. Everyone forgets that it's a parallelogram and always forgets these properties. Parallelogram properties apply, and they have a couple extra ones that the parallelogram does not. Good on a rectangle before I get to the rhombus. All right, the rhombus also is a parallelogram. Where's my rhombus? There you go. It's also subs in as my parallelogram. Plus a couple extras. The first extra, all sides congruent in a rhombus. All sides congruent. That doesn't happen in a parallelogram, and it doesn't happen in a rectangle. Only for the rhombus. Only for the rhombus, all sides equal. All right, diagonals are beasts in a rhombus. They are beasts. They do a ton. First thing they do, they bisect the angles. So here's what I'm talking about. Bisect the angles. Congruent, congruent. Congruent, congruent. They bisect the angles, and they're perpendicular. So where they meet forms a right angle. Right? So where they meet forms a right angle. So all 4 sides congruent, bisects the angles, and they're perpendicular. Right? I'm not expecting anybody to know these by the time you leave, but tomorrow when we do the proofs, we got to know them pretty quickly. All right? Because today's all the algebra with the properties, tomorrow's proofs with the properties. Anything I can answer about those 2 figures. Please keep the properties separate. All right. All these special properties I just talked about in a rhombus do not exist in a rectangle and do not exist in a parallelogram, only in a rhombus. All right, let's jump right into it. Let's see what we got. Please do not start going ahead of me and start finding the numbered angles. That's not your first job. Your first job here is These four are all parallelograms. I'm telling you, they're parallelograms. Give me a better name based on the markings I put on now. Great, they're parallelograms, but because they have these markings, let's give it a better name. So number one, it's a parallelogram, but notice I threw a right angle down here. So if I have a parallelogram and I put a right angle in, now it makes it a rectangle. Okay, makes it a rectangle now. A parallelogram with a right angle. I don't need all four, just one. Makes it into a rectangle. All right, let's go with the numbered angles now. I'm going to go out of order. I'm going to go angle 3 first because that's the easiest for me to find. And hopefully you too. Boom, angle 3. Anybody see it? Angle 3, Will. 18. How did he know so quickly that it was 18 degrees? It's a parallelogram still. Opposite sides are parallel. What type of angles are 18 and angle 3? Alternate interior. It is a parallelogram still. Good. So I'm going to put an 18 here. All right, let's go angle 4. Let's go angle 4 on you. The diagonals form 4 isosceles triangles. So these two are equal, meaning if that's 18, that's 18, and I know 180 degrees in every triangle. All right, see how I know? You know, I'm doing this one for you, but notice if we know our properties, it's not that bad. So angle 4 ends up being, what do I have there? 36. I don't know, somebody help me out there. 140, excuse me, thank you, 144. Good. So if angle 4 is 144, I could probably get to angle 2 pretty quickly too. Linear pairs are supplementary. So that would make it 36 degrees. 36. And now everyone ready for angle 1. All right, bunch of ways you could get to angle 1. Here's how I'm going to get to it. The top triangle is isosceles. So if that's 18, this is 18. And what do we know? All angles in a rectangle are right angles. Right? They're right angles. So I can do 90 minus 18 and get angle 1. 90 minus 18, get angle 1. And that's going to be, come on now, 72 degrees? Not even, yeah, 72, right? No? Yes. Yeah, thank you. Perfect. Any issues there? And again, I'm going fast here. I'm going to let you guys do some on your own in a sec, but just want to show you if you know your properties, this can go quick. 2, it's a parallelogram, but I made all 4 sides equal. A better name for it would be rhombus. Yes, all sides equal in a rhombus. Watch how quick this goes, knowing our properties. Watch how quick this bad boy goes. First one, I'm going to go angle 1 right off the bat. Angle 1. Angle 1, 59. Alternate interior angles are congruent. Lines are parallel because it's a parallelogram. Watch how quickly this goes. 2 and 3 are both the same. Just a property. That's it. It's just a property. Diagonals are perpendicular. So what type of angles do I have there? Right angles, 90 degrees. Diagonals in a rhombus are perpendicular. Right angles. And now number 4. Angle 4 is a property as well. Diagonals bisect the angles. So that has to be 59. Yep. I didn't even need to touch the calculator. Didn't need to touch it. All right, that all just came from properties. All right, I'm going to do number 3A with you, naming this figure, and then you guys can finish 3 and 4. Okay, don't give me this business. Oh, it's this figure because it looks like it. Baloney, not in an honors level class. We don't pull that business. I need to somehow mathematically prove what this is, right? So before we say what it is, hey, anybody got an angle 2 for me? Because I already know it's a parallelogram, right? I already know it's a parallelogram. Matt, what's angle 2 going to be? 30 because it's alternate interior with the given 30. All right, so let's go back now to part A. If that's 30, I have a 60-degree angle next to it. Oh, this is a right angle now mathematically, not because it looks like it. Makes it a parallelogram with one right angle. Rectangle. All right, so you guys are responsible now for finishing the rest of those. Do not go on to 5 or 6, please. Just finish 3 and 4 for me. You guys can work together in your groups. Don't move around. Go ahead, talk it over. How do you find these different angle measures?
Wait, so all it needs is one right angle for it to be a rectangle?
Got to be a parallelogram first, Matt. I can't. A quadrilateral with the right angle is not necessarily a rectangle. It could be a trapezoid, a kite, okay? But a parallelogram with a right angle is automatically a rectangle.
So in the previous, are we gonna have to solve like it's a parallelogram and solve the rectangle?
Oh, look at you again. Yep, thinking ahead. Yeah, that sounds like fun, huh? Yeah, it does. Yeah, it does. That sounds like fun. I can't wait either. Oh yeah, we're gonna have some fun with these proofs. However you get there, I am not impressed with how many steps you can get to an angle. Right? However you get there, how you finish. We ready? Okay, let's go around here. We already know angle 2 and number 3, so let's go angle 1. What did we get here for angle 1? Start this off. Boom. Speaking of 1, Charlie, 22 degrees in. You're going to jump in on me to angle 4 here? Are we number question 4? We're still on question 3 here, stud. Angle 1. 60. Yeah, that's what I thought. Yep, relax. Just trying to show off, I think. Next up here, Olivia, I got angle. What angle am I looking for? 3 in problem 3. 60 degrees looks good to me. And then how about angle 4 to finish this off? 4. How about that, Doyle? 30. Yep. Maybe because I somewhat like some of you, not all of you yet, but some of you. What I've done in the past 2 of classes that I've really enjoyed is if the answer is the same number I call on, then no homework as well. You know what I'm saying? You know, so that's something we've. Oh no, it's you get to guess the next slide transition. I'm not going to give homework out that free, but that's also too. Like if say angle 1 ends up being 12 degrees, and I call on number 12, then we guess the next slide transition. You see what I'm saying, Josh? Okay, good talk. All right, you ready? Number 4.
And
What do we?
If we get it right, we get
The slide transition, yeah. But you're not going to get automatic no homework.
Does everyone vote or just person?
No, we do the same thing we usually do if the Promethean person came up. All right. See, now I'm recording this, and period 3's hearing this, and maybe I don't like them as much as I like you guys, so they're going to start complaining. You know. So. All right, rhombus, everyone. And just let me talk here real quickly. I've been showing all 4 sides congruent to make a parallelogram into a rhombus. I don't need that much. And this is just showing you what we're going to be doing here tomorrow. Say that's a parallelogram. Anybody know why that's good enough to show it's a rhombus? I don't need all 4. I just need those 2. Why, Zeke?
Parallelogram, opposite sides.
Remember, it's a parallelogram. So if opposite sides are congruent, that automatically makes those 2 and all 4 now. All right, so think about that. Starting tomorrow, I don't need all 4. I just need 2 if it's already a parallelogram. All right, angle 1. You don't have a shot anyway in these if we don't go high enough. 15. Gabby, what do you got? Angle 1. 20. There's your 22. Yep. Angle 2. Charlie? 68 degrees. Angle 3. 8. Josh?
For 3?
Yes.
68.
68. And let's finish this off right. Angle 4 for number 4. 14. Gianna? 90 degrees. There you go. Okay, everyone good? Comfortable? Anybody want to go over any of those angles and where they came from? Those are the angles. Now let's talk about the sides and the diagonals before we end class. All right, we got rectangle, HIJK. Quickly, because this will mess up the problem. How do you label it? How do I label this? Yeah, yes. Clockwise or counterclockwise? Because if you start jumping diagonally, it throws off where these should go. All right, so clockwise or counterclockwise. H, well, not those. H, I, J, K. And in this problem, we're looking at H, J, and I, K, which are the diagonals. If you label this wrong, it's going to be your sides. And then you're like, what the heck do I do? So we're talking about the diagonals, 3x plus 5 and 5x minus 9. What do you know about the diagonals of a rectangle that's going to help me out here? We're going 7. Good talk, Amy. Good talk. 6. Thomas, what do you know about the diagonals of a rectangle?
They bisect each other.
Okay, and I'm thinking about what do I do with this 3x plus 5 and 5x minus 9? Because the HJ is 3x plus 5, and the IK is 5x minus 9. What do I know about those diagonals? They do bisect, but it's specifically for a rectangle. They're what? Diagonals of a rectangle. What's it say there? Congruent. So that allows me confidently to set this up. Right? That allows me confidently to set that up. Solve for x. I think x comes out to be, what do we got here? 7. and read the problem and the length of each diagonal, right? Find the length of each. So hopefully when you plugged it into HJ and into IK, they were both the same value. And when you have that value, let me know. Let me know. Where am I going? Ian, when you're ready. 26, yep, for both. We're all good? Any issues? Okay, we got a rhombus now. We have a rhombus. One diagonal is 8, the other is 6. Remember, they're not congruent, so they shouldn't be, because it's not a rectangle. This is a rhombus. Find the length of a side now. How long is a side? All right, let's talk about the 8 and the 6 they gave me. Those are diagonal lengths. So now the mind starts going, all right, what do I know about diagonals of a rhombus? Diagonals of a rhombus. Throw anything out here. We may use it, we may not. Diagonals of a rhombus. What do you know about them? 1-4, Gianna, what do you know about them? Okay, so that diagonal of 8 is going to become 4 and 4. The diagonal of 6 is going to become 3 and 3. So a little more detail. All right, keep going with me. What else do you know about diagonals of a rhombus? 16, going deep, Zeev. Oh, okay. Oh, all right. So they're perpendicular there. Yeah, okay. So wait a second. I see a little something here. I see 4 of them, but I'm only going to focus on one of them here. A right triangle? How many sides do I know there? 2. Do I have a device that if I know 2 sides, I can find the third? Only in a right triangle. Little thing we like to call Pythagorean theorem. All right, be ready to use this bad boy, especially with the rhombus, because you form 4 right triangles. Remember, A and B are the 2 legs, the ones that form the right angle. So for us, 3 squared and 4 squared, and C is the hypotenuse across from the right angle. That's what we're trying to find, the side. 9 and 16 equals C squared. 25 equals C squared. Take the square root of both sides. That side is 5 units long. Okay, so be on the lookout, especially with a rhombus, because it forms 4 right triangles. You may use Pythag. Any questions? Okay, I did just realize